calculate that also from the principle of image formation. Okay. The image from the mirror has one more interesting thing. That is, it has what we call the what is reverse front to back, right? When you look at the mirror, if you look at your face, if you look at your hand, you can see your hand, but it's reversed. Okay, if you look at the image of the character of a character in the mirror, and you can see that it's inverted. But sometimes someone think that it's invert like the left to right or right to left, but it's not right to left, but it's front to back, right? Because the light that travel from your hand go to the mirror, and then it travel back in the same direction. So it's like the light go like this and then go back in the same direction. It's not like it's go like this and then it's revert. No, it's not left to right, but it's front to back. So that is the image, the property of the image of the mirror. Okay. Next thing that we have to know when we talk about the image from the mirror is what we call the lateral magnification. Lateral magnification. The lateral magnification tells us the size of the image relative to the size of the object. Normally, when we talk about the lateral magnification, we talk about the height of the image, the ratio of the height of the image to the height of the object. And for the plane mirror, we know that h prime is equal to h. Okay, so the lateral magnification m is equal to 1. Okay, it's equal to 1 because we can see the same size of the image when we compare with the size of the object. Okay, but there is something about the size when we calculate the lateral magnification that we will talk about this soon. Now, what is more interesting? What is more interesting is the image from the curved mirror, the concave mirror or the convex mirror. Now, if you bend the mirror from the flat mirror, you will get the concave mirror like this. You will get the concave mirror like this. In fact, we have many kinds of concave mirror, but the concave mirror that we discussed here is maybe the most the simplest configuration of the concave mirror. That is, we will discuss only the concave mirror that the surface of the mirror is a part of a sphere. Is a part of a sphere. Okay. It means that if you look at the surface of this mirror and you extend the curve, it will be the sphere. Okay. So, if the surface is a part of the sphere, you can define a point here that we call the point C, and we call it the center of curvature. The center of the curvature. We use this at the center of curvature. The meaning is that if you extend, okay, if you extend the surface to complete the sphere, the point C is the center of the sphere. But since the mirror is just a part of the sphere, it's not a complete sphere. So we don't call it the center, but we call it the center of curvature. It's not the center of the mirror. Okay? When we talk about the center of the mirror, it always means this point. Okay? It always means this point, the center of the mirror. But point C, the center of the curvature. And when we discuss about the image from the mirror, there is also one thing that we need to define, that it is a principal axis. The principal axis is the axis that if you half the mirror like this, you can see that this is the center of the mirror. It means that you can half the mirror, and then you draw the line that is normal to the tangent of the mirror at the center of the mirror, like this. Okay, this is normal. So we call this the principal axis. This is the line that passes through the center of the mirror. Pass to the center of the curvature and pass to the center of the mirror, and we call this the principal axis. And in this class, we will talk about the object that close to the principal axis only. We will discuss the image of the object that placed near the principal axis only. If the object placed far from the principal axis, we have to do something different, and it's more complicated to calculate the image from the mirror. Okay. Anyway, the principle that we use to calculate the position of the image is the same. If we have an object in the form of a point object, a small object here, and the light from the object travel to the mirror and then reflect back, the position of the image is the point that is the intersection point of the light that reflect back from the mirror. It may be the real intersection point, or it may be the point that the light is not really intersect, but it's like if we can trace back the path of the light and it intersects somewhere, and we call that the position of the image. Okay, so it is the same principle as in the flat mirror, and we can calculate the position of the image using find the intersection of the light ray that reflect back from the mirror. Okay, this is an example of the light ray that reflect back from a curved mirror. Okay. We will talk about this soon, that if you have light that travel like this, it means that the light ray, these three light rays are parallel. And if these three parallel rays reflect back from a curved mirror, it will intersect. It will have the intersection point here, and we will call this the focal point. We will talk about this soon. Okay, so this is an example of the real image of the reflection from a curved mirror. One thing that you have to be careful, that the mirror that we study here is what we call the Is it like a thin mirror? For example, that we say I say that the mirror is the surface of the mirror is a part of the sphere, but it has to be a small part of the sphere. You cannot take the mirror that is half of the sphere like this and use the formula that we will discuss after this. You cannot use the formula in this chapter to calculate the image from the half sphere mirror. You cannot do that. But if it's just a small part of the sphere, like if you have the big sphere like this and you cut only the small part of the sphere to be your mirror, it's okay to use the following formula. You can test this very easily by you may draw the half